Hi everyone. Uh, this is again. Not sure this is recorded. Skip this version. Remind me later. I tried to explain about. Unfortunately, my previous lecture was was not possible. Let me see what happens. Let me see if I can continue to get this. So if you have Wireshark, then you can see you can connect like this. Okay, and then if you see some of, I want to stop some of those, and if this is TCP, okay, then TCP has a transmit control protocols, TCP. So TCP has a source port number and destination port numbers, right? And this is first attached, and then next, when we want to detach it, I mean unpacked, then this one first unpacked, and the next one is this Ethernet, which is the MAC address, destination and source MAC address, that is unpacked, and the next one is the IP related metadata can be attached from network layer. So if you see here, there is a source address and destination address, right? These things can be available, for example, TCP header structure. Then hopefully, yeah, that is there. So source port and destination port, sequence number. Each of these explained here, right? And if there is a flags, then the flag information there. Flags occupy the 8 bits. So from these are the bit numbers from 0 bits to 7 bits, 8 bits. Each of those bits indicates this kind of flags. Okay, so those are, this TCP header can be found from let me close this. So in each packet to the data payload, the first header data attached to it is TCP or UDP. Anything that can be about transport layer. So there is a source port number and destination port number. That is this, right? So each of these sequence number 7264, that is a sequence number here. And acknowledge number, that is also 4 byte long. Then I think, yeah, acknowledge number here. And the flags, hexa code 010, that is the flags. You can unfold this further. So there's a nonce and congestion window reduced CWR. It is not set because it is 0. There's a something set acknowledgement 1. So if you come back here, acknowledgement ACK, that is set, and all others unset, which is 0. So 0, 0, 0, 0, 1, 0, 0, 0, something like that. Okay, so you can open this TCP, any protocols from your Wireshark. Similarly, this can be captured not only by this tool. This tool is very nice and beautiful. You can play with this manually. Yeah, but because you guys wants to be cybersecurity professionals, then you need to go further, a couple of more steps. One of them is that you can code to inspect the packets, analyze packets, not only manually like this, but you can look at those hexacode and identify what it is. What it is means whether that is acknowledgement to flags set or unset. Those things can be identified by your coding. Okay, those who wants to do more and deeper, then you can find it from one of my books. These are the books written by me. I believe this is the book, Hacking Network Python, Circuit Programming for Packet Analysis and Inspections. So this book shows you details, all the source code as well. A lot more than what you can do from Wireshark, but Wireshark is semi-manuals. But if you do code, then automatic, it can go further continually. Only it can capture something that you want to. If there is any attack, any sniff, any spoof, any kinds of attacks may be inspected. All right, so I'm going to close this. And the next module that I want to share with you is the protocols. I'm not going to present this, because when I present this, what happens is the recording is not successful, I guess. So I'm going to, so far it is being recorded well. Okay, so I'm going to use this rather than a presentation. I know what happens. Anyway, that happens. Okay, it's a long story. But anyway, yeah, these things can be also described on the book that I wrote, but I am going to explain to you here some of the packets as you inspect. The first thing that you need to find out is in the packets, the Ethernet packets, then you can see some of the code 0806 or 0800, depending upon that. If it is 0806, then that is ARP. 0800, then that is IP. So so it goes further to, if it is an ALP, then as I explained here, once Ethernet type is 0806, it is an ALP packet address resolution package. The source device seeks to perform the resolution, and the destination device responds to it. An ALP message includes a field describing the type of messages. So an IP address is this. Depending upon that, you can inspect it. If you are going to use, if you're going to inspect from your Windows, then you can get only, I believe that is only IP things. ALP can be done if you could do an MacBook or Linux and Unix platforms. For Windows platforms, you can capture it from IP and above. So that is detailed, described on that book. And then this slide that I want you to learn from this slide, the difference between UDP and TCP. So I wanted to make sure that UDP is a datagram protocols. So there is a connect list, which is unreliable. Application usually message based. So no error can be handled. Error cannot be handled by this UDP protocol itself. If there is an error, if you want to fix it, then you have to do it extra, if it is UDP case. TCP case, there is a connection based. So that is reliable, stream based. Application does not need to check, because the error can be checked and then corrected. This TCP protocol itself. So no additional work to be done at the application layer. However, UDP, then application needs to do that, because the protocol itself does not do that. And data structure, the header structure, as you looked at, it has a source port, and destination port, and length and checksum. That is UDP. And then TCP even further. ICMP, usually if you want to share, for example, ping, network trace, then that can be done through these protocols. So on this slide, we'll look at the hands-on and socket programmings. Socket is nothing but this. Through the socket is nothing but the port numbers. Okay. In order to build TCP server or TCP client, UDP server or UDP clients, then you need to first create a socket object. Once you create a socket object, then whatever available method in that socket object needs to be used to communicate. For example, send to method, receive from methods. Those are the methods that you need to use to communicate between server side and client side. But we will do both for TCP protocol or UDP protocols. So I want you to read that. And the following, this is a very, very important a slide that I ask you to remember. This is setting for most of those server side and few also client. But in general, I want you to understand like this. Two columns, UDP and TCP. As I said, the UDP is a connectorless. TCP is a connection-based. But both start with the creation of an object. So you need to first get the object, the socket objects. Socket object can be defined by the class called the sockets. This is a constructor. For UDP, you can say both are described here AF underscore INET. And then second parameter for UDP, sock diagram. And for TCP, sock stream. If you have a sock stream, then TCP socket is created for TCP protocols. If you have a sock diagram, then socket object is created for UDP communication. Once sockets are created, then you need to open up port numbers, and you may designate any client IPs. So sock.bind is a method or function. My sock, there is an object.method. Remember that when we look at object orientation, right? That is this. So object.method, this method takes an array, the tuple. Remember that here? This is a function. Outside the parenthesis, that is a function. But inside there is another parenthesis. What it means is that the this function, bind function, takes a parameter in a tuple formats. Remember the tuple? Tuple is in the parenthesis. First element in that tuple is IP address. This IP is a remote client IP. And then second parameter, second element in that tuple, that is the port number. Port number that is open for either UDP communication or TCP communication. If you want to open for any the client, excuse me, any IP address for any client, any remote client, then you should say quote, unquote, no space in between. If there is a space, then space itself taken to see if there is any IP address, which is nonsense, right? So you need to have quote and unquote, no space in between. If you want to wait any specific IPs, then you need to say that IP address here. Then either server waits only this communication from this the client IP address through this port number. The next one is very important. As I said, the UDP is a contactless. Therefore, there is no connection built. UDP connection based. So the object of UDP sockets, object of TCP sockets, dot listen. This is a function. So that socket object listen if there is any client to knock. If there is a knock, then this socket listening and create by accepting that request as accept. Remember that here, my sock.accept, this is a function. The result of this accept function evaluation is two things: connection and tuple of another tuple, right? Connection objects, and in the tuple we have remote IP and remote port numbers. Remote IP, remote port number. Therefore, this connection continue to designate, hey, I want to talk to that IP. I want to talk to that port on that IP specifically. After this connection constructed for TCP, then connect object itself can receive and send data. On the other hand, this is a connection based, right? On the other hand, if there is a UDP, then there is a connection list. So there is no connect object. But throughout whole, only socket object work. For UDP communication, that socket object receive, socket object send. See the difference, right? Socket object, because there is no connection created, connection built. Socket can work. For TCP, socket once accept the request from client, then connection is built. Therefore, from that point, connection object will exist, continue to receive and send. Okay. And that is explained some here. And then I will explain some of the sample code that you will work on. This is a connect list, which is UDP. So socket is created by sock diagram and bind, and then receive and send data by socket itself, right? S is the socket. Socket itself receive and socket itself send to. This is server side of UDP. Client side, also socket is created. Socket object is created for UDP protocol, which is a sock diagram. So this is a socket object. That socket object can receive. That socket object can send. This is UDP. For TCP, this is TCP diagrams. For TCP object, TCP socket object can be constructed by sock stream. So S is a socket object. This socket object listen. This guy, the number one means I wanna listen one connections. Previously, it's I think somewhere here. 5 means I want to handle 5 connections. One connection, and then there's a request for connections. Therefore, this socket, TCP socket object, accept it. By accepting this socket object, then construction is created with the remote IP and remote port numbers. From that point, this connection object can send data, connection object can receive the data. Okay, this is a TCP communication. Client side for TCP, same thing. Socket object is constructed. We call that client sock. And then that's client sock receives data, client sock send the data. Here, these sockets, these two also respond to the server side, because the server side wants to construct a connection by accepting it. At the client side, also respond it, hey, construct the connections. Okay. This is it. Based upon this, next week, I'm going to post, I think, 3 recordings. One recording that can be done on Windows systems. The other recordings Mac OS systems. Both will look at UDP communication and TCP communications. So you need to have server-side code and client side. And client can communicate to the server, and server can respond back to client. Separately, one time for UDP and another time for TCP. Okay, and then third records is for both Windows and MacBook. MacBook can do for server. Windows cannot do the server if they need to talk outside devices. Okay, so Windows can do only a client side. So if you guys have MacBook and then Windows, then you can practice it. Anyway, I record it, and then you can see how they are working. One assumption there, because the 2 different devices needs to talk, then router needs to understand both IP address. If you have static IPs publicly, then you can use it. But usually we do not, right? I do not. It is a cost. But you can still practice it. You can set up the MacBook and the Windows PC under the same router at home. So router can create IP address for both your local devices, right? You can use that private IP address, not the public IP address. Then they can talk. All right. So look at that video clips. So final homework assignment will be a practice of those. I do not want you to do the third cases. 2 different devices needs to be talked, but rather for your homeworks, either if you are working on Windows, you can do that only for Windows. You can do that only for Mac OS. So you can selectively watch the video clips and follow it and do the same thing that I do on the recordings. You do not need to do anything additionally. All right. Hopefully this is recorded. By the way, today I recorded it from the first half of the my PowerPoint slides presentation, but it didn't go through. Now I know partially if I do PowerPoint slide presentation and the recording, then recording is not succeed. Now I did it like this. This is not presentation, right? All right, I'll stop here and I'll see you next week. Have a good